Mrs. Shomana Gracia Jacob, ME in Computer Science, lecturer in CPET, Chennai for the past 3 years. She has published 4 national and international papers. She has won Star Achiever Award for academic proficiency.
Welcome to the UGC lecture series in computer science. In today's session, we are going to see about how to process data files, the concept of binary files, how to copy one file from one file to another, and so on. So, what are the operations that are to be performed on such files and what is the syntax that is involved. So, the overview of today's session is how to process data files. Processing is nothing but updation of data files, rearranging of data files or records in a data file, copying data files, and in certain detailed features about unformatted data files and binary files. Processing data files, what does this involve? This involves adding new records either at the end of the file, which is nothing but appending records, or interspersing in between existing records. It is not necessary that when you have to create a file, only those records which you insert at the beginning are to be maintained continuously. For example, you just have to take a student database also, student file also. Students may enter in at different times. So, within a month there may be different entries of students with different names. So, when you want to arrange them according to the roll number or in the alphabetical order, if you have already created a file with a certain list, when another person comes who has to be inserted somewhere in between, you should be in a position to do it. So, files need to offer such kind of flexibility. So, not only should data be added at the end of the file, but also in between according to the application's need. Updating existing records, the address of students may change, their roll numbers may change, their IDs may change. So, all these things also have to be kept in mind and they have to be modified accordingly. Deleting records, a student may leave the institute, in which case you have to delete his record. Rearrange the records within a file. So, this may be done just for the user's need. Whoever is using that particular file may like to rearrange it and set it in a manner so that it will be easy for him to understand and retrieve records according to his convenience. So, all these flexibility should be provided when you are accessing and working with files. So, this is done with the help of the processing feature available with data files. So, what are the approaches, how you are able to do this with files? The most common approach that is used is you have to read each record of the data file. You have to update whatever record you desire. For example, you may not have to update all the records. Somewhere maybe 2 or 3 records you may have to update, or 100 records at a time, depending upon the size of the file. So, whichever record you want to update, you have to update it, write the updated record back to the same data file. So, here you are having one data file which is the source file, you are reading each record from it, whichever record you want to change, you are changing it and writing it back to the same file. So, there are certain disadvantages with this type, though it is commonly used. When you are writing the updated data in a formatted manner to the data file, it is a very Herculean process. It is quite difficult to do it because you have to write it back in the same format after updation. So, it takes a lot of time. Existing arrangement of records in the file are disrupted because of this. So, when you are trying to update one record and write it back with or without your knowledge, you may disrupt the already arranged set of records, in which case it causes inaccessibility to those records, like the programmer would have been working with that arrangement for a long time. Because you want some updation to be done, you update it and you write it back in the same formatted manner. This may you may have unintentionally caused some rearrangement of the existing records, in which case the person who is using that file already having a plan, he already has a plan of which record is available where in the file. So, because you have disrupted that arrangement, when he is trying to locate one particular data which he has already seen, but is currently not in that particular place in the file. So, this irritates the person who is using the file. At the same time, he gets upset whether he has deleted it or whether it is existing in that file or not. He has to search for it and then retrieve it again. So, in such cases, inaccessibility to records is caused by this approach. So, that is the reason they have moved on to a different approach which uses 2 files. The record is read from one source file and it is updated, but it is not written back to the same file. You write the updated record to a new file. After all the updating is complete, 5 or 10 or 100, the old file is deleted or displaced in archival storage. the new file is renamed. So here the source file from which records have to be updated, you read each record, whether you update it or not, you store it in a new file. What records don't need updation also you store in the new file, what records need updation you update it and store it. So after all the records, after the full file has been read and completed, you delete the old file or you place it in archive. Archival storage is a storage which is taken only when you need it, otherwise it is just kept like that in storage. It will be there, you can access it whenever you want. It is a big storage memory space, but it does not affect the operation of the system. After you delete that old file, you have to rename this new file into which you have written the updated records to the same name. So what are the advantages of this approach? It provides a series of old source files. So after each updation you are keeping that source file in storage, means you can create the customer history. In certain cases you would like to know which customer updated which record, what was the state of the file before that updation, what is the state of the file after that updation. So all these records can be kept in archival storage if you follow this approach. And the most recent source file can also be obtained for recreating the file in case of damage. Say you have made all the latest updations and you have kept the file, the old file. Say the computer hangs up or you have lost, somebody has unintentionally deleted that new file. Then it is easy to recover the data in the new file if you have the oldest source file. Only the latest updations you will have to do, because all the previous updations will also be stored in that old source file. So in the case of damage or loss, it is easy to reconstruct that file. Okay, so that is these are the advantages of using this new approach. So now people are coming to this stand of using this new approach more commonly because of the disadvantages in the older one. So next we are going to see how to copy the data files. So we have seen about the methods of processing. Now we are going to see how to copy. You are having the main function, you are having 3 character variables. One is an array, 2 are arrays and 1 is a variable. So now you are going to copy the text from one file to another. You are having the file, you are creating 2 pointers fn and fout. As we all know, you want to copy, so you have to read from one file and write into another file. That is the reason you are having 2 pointer variables. So first you have to know from which file you have to read. So you have to enter the source file name, getters of inf. So inf, that array is used for getting the file name. It may be of any length, that is why we have kept the size of the array to be 50. Next you are checking if fn is equal to fopen, opening the file inf in the read mode, whether it is possible, whether the file is existing, whether it is having data. If it is not having data, if it is equal to null, then you printf, you cannot open the file and you exit the loop. You cannot continue with the program because the program itself is to read and write. When you cannot do the first operation of reading, there is no point in proceeding with the program. So you exit the loop. You printf, enter the destination file name into which file you want to write the data. You get that particular file name and again you check whether the file can be used for writing. So in this program, if you see, we are checking whether the files can be read and written simultaneously. That is, after you check whether the file can be read, immediately you are checking whether the file can be written. This is because you are going to copy data from one file to another. Just imagine a situation where you check whether the file can be read, find the file is existing, it is having data, and you read all the contents. After that, if you check whether the destination file is ready for writing and you find a null value over there, what will you do with the copied contents? You need not have taken the contents from that file at all. So when you want to copy information from any number of files to any number of files, you first have to check whether all the files that are to be read and all the files, whether they are to be written, whether all of them are in condition, whether they are capable of satisfying this copying process. So after you check the fn statement, immediately you check out the fout statement and you open the file for writing, check whether it is null or not. If it is null, you simply say you cannot create the file also and you exit the loop and exit the program. Now say in both the cases, if the file is ready for reading and the file is ready for writing as well, then you proceed with this loop. So you have to check, you have to first read. So you check for the file end of file function of fn. If the file is not ended, then you take the character get c of fn, store it in the ch variable. You are reading character by character over here. Then you put c, that ch, in fout. Fout points to the outer file, that is the file name which is to be stored, where the data is to be copied, and finally you fclose all. So here if you see, the loop starts over here, the while loop starts over here and it ends over here. So the loop will keep on executing till the end of file condition is reached. So till the file end of file condition is reached, the data from fin will go to ch and the data from ch will go to fout. So after all the characters are read and the eof condition is satisfied only, it will come out of this loop. So after this, all the function is over. The reading, this is for reading, this is where you read the data and this is where you copy the data. Here again if you see, it is being done simultaneously. As you read one character, you are writing it. As you read the other character, you are writing it. And after one line is completed, we already know that the pointer automatically switches to the next line. So here copying is done simultaneously. So because both the functions are over, you can just give an fclose all, or you can give fclose fin, fclose fout, both of them make sense. So this is how you read and write files as well as copy the data. In the last session we had seen a program on reading and writing where we read all the data and then we wrote it. But for copying, you have to do both the operations side by side, only then copying makes sense and it is fast. So what are the points to be noted here? Data files consisting entirely of strings can often be created and read more easily with programs that use special string oriented library functions. So we have already seen the string functions in C. We have string length, string concatenation, string compare, string copy, string break and so on. So when you are having a file with only characters, it is very easy to use the library functions and perform the operations. Data files consisting of complex data structures, like we had already seen, unformatted data files which consist of arrays and structures, they can be processed using the library functions fscanf and fprintf only. We already know, now see, putc and getc have no arguments at all. You just have to say getc from which file name, putc what character into which file name. Whereas in fscanf and fprintf you have around 3 arguments. You have to identify from which file you are going to read, what type of data you are going to read, and you have to give the data as well. So you have to remember the format specifiers, whether it's %f or %d or %u and so on. So those are the advantages when you have text files which contain only strings. Whereas when you work with binary files or unformatted data files, the syntax becomes more complicated. Next we move over to unformatted data files. Unformatted data files consisting of multiple structures having the same composition or multiple arrays of the same type are called unformatted data files. So here multiple arrays of the same type, that is integer and you have plenty of arrays, float and you have plenty of arrays, or you have structures. We know that in a structure you have several variables of different types. So when data files comprise of such data, they are called unformatted data files because you cannot define the format for it. While reading you cannot define what type of data you are going to read, because in a structure you have plenty of variables. So in such cases it adds complexity to the reading and writing or copying process. So that is the concept involved with unformatted data files. You cannot have the same protocol for reading and writing data. In such cases, it may be necessary to read the entire block from the data file or write the entire block to the data file. So that is the difference. This is how you handle the reading and writing process. So now we will see after the break how these unformatted data files are used for reading and writing purpose and what are the functions used in them. Welcome back after the break. So we had been seeing about how to process data files in C, how to copy data files, how reading and writing functions are done simultaneously, and now we moved over to unformatted data files, when unformatted data files are used, and how do we write and read data into these data files. So what are the functions used in these unformatted data files? We know that in unformatted data files you have to read continuous blocks. It is not single characters like we do in a text file. So for that we use these fread and fwrite functions. These are the library functions used to read data from such files and write data into such files. Hence they are called unformatted read and write functions. So now we will see how the syntax of these functions are defined. Each of the unformatted data functions, that is fread and fwrite, requires 4 arguments. 4 arguments in the sense 4 parameters. So, this is the example. You have the F write. The first argument is ampersand PTRD. The first argument is ampersand PTRD, which indicates the pointer to the data block. Next, you have the size of the record, which indicates the size of the data block that is to be transferred. Next, you have 1, which indicates the number of data blocks to be transferred, and then you have FP, which indicates the stream pointer. So, what does each of these arguments indicate? So, for fread as well as for fwrite, both the functions, all these 4 arguments are there, and all these 4 arguments have the same meaning. So, in fwrite, first you have PTRD, which is the pointer to the data block. As we all know, in an unformatted data file, there may be a number of data blocks. So, which data block is to be read? For that reason only we have this pointer. The size of the data block, how much of data block is to be read? What is the size of the data block? All data blocks will not be of the same size, because in an array you may have 5 elements, whereas in a structure you may have 4 variables or 5 variables of different types. So, the size of the data block is important. The number of data blocks you are going to be transferring, mostly this is by default 1. At a time we transfer only 1 data block, but this is present in the argument because we have to indicate, just for a indication of how many data blocks are to be transferred. And then you have FP, which is nothing but the stream pointer. The stream pointer is nothing but the pointer with which we open the particular file with that particular file name. So, in fread also the same arguments have the same meaning. Next, we move over to binary files, and then we will see example programs involving both these file operations. Data files are commonly called text files. Text files are what are normally used in any program. Binary files differ from text files in 2 ways. One is storage of new line characters and the EOF character. So, new line characters, as we already said, once you are reading or writing into text files, automatically the pointer moves to the next line, and the EOF character identifies the end of file. When you are reading from a file, you have to know where you have to stop reading. Once the file is ended, you have to stop reading. So, these two are different in binary files. So, what is the difference? The new line character in text files /n is stored as a single new line character, but it occupies 2 bytes of storage. So, though it is only 1 line, it occupies 2 bytes of storage in memory. 1 byte is for the carriage return, which indicates that you have to return to the beginning of the next line. The other byte is for the line feed. Line feed is in order to accept the next line that is being typed. In binary files, this takes only 1 byte of storage. So, this is the difference related to the memory allocation. The same new line character in text files, it occupies 2 bytes of memory, whereas in binary files it occupies only 1 byte of storage. Next, the EOF character. Every text file is terminated with the EOF character, which is automatically assigned by the compiler. It has an ASCII code of 26. We all know that though they are alphabets, when it is interpreted by the compiler, it takes it only as the ASCII code, like small a and capital A, this being a case sensitive language. In binary files, there is no such explicit EOF. So, this is what is very important. So, when you are reading binary files, you have to make sure you use some other method by which you identify. What method? The size of the file, to identify where the file closes. Their end of file is verified by their size. That is why the size of the block being transferred is present as an argument in fread and fwrite. If a text file is opened in binary mode for reading purposes, now remember this, a text file is being opened in binary mode, it is not a binary file. A text file being opened in binary mode for reading purpose, it may detect the end of file wrongly as result of a particular data with an ASCII code 26. So, this is the problem with binary files. So, a text file should be opened only in the default mode of reading and writing, and a binary file should be opened in the binary mode. If by mistake or if for some reason a text file is opened in the binary mode, their end of file will be recognized as some digit with an ASCII code 26. So, it is meant only for the text files. In binary files, 26 has a different meaning. So, if you are going to open a text file in the binary mode, it will not accept 26 as the end of file character, because binary files do not understand what is meant by end of file. For them, the end of file is their size only, not any ASCII code. So, that is the reason this end of file makes a difference between the text files and the binary files. So, in the case of a question between the difference, one is in the storage of memory for new line, the other is in the end of file. In text files, it is the ASCII code 26, whereas in binary files, it is just their size. Next you have the storage of numbers. Numbers can be written to the file, that is binary files, using the fprintf statement. This is similar to text files. This statement stores numbers as a sequence of alphabets. So this is where it is different. Numbers can be written, but they are stored only as a sequence of alphabets. Putc and fputc statements cannot be used for these purpose. So in binary files mostly they are having only numbers. So when you are writing it also you have to use only fprintf, because putc and fputc are used only for characters. So those two functions do not have any work in binary files. Everything in binary files is using fprintf and fscanf only, unlike text files. All machine language files are binary files. To open a binary file, the file mode needs to be mentioned as RB or WB, that is read binary or write binary, in the fopen statement. The fopen statement only you mention, isn't it? What type of, for what reason that file is going to be used. So there you have to mention RB or WB, R or W. R or W is the default mode for text files, RB or WB is the mode for binary files. If the mode is not explicitly mentioned, it is taken to be the default mode, that is to open text files. So here again there will be a problem. If you are opening a binary file and you forget to mention the mode is RB or WB and give it as R or W, or you do not mention at all, it will open that binary file in the text mode. And if it identifies an alphabet with an ASCII code 26, then it will take it as the end of file and it will stop reading. So vice versa the problem will occur. That is the reason R or W is equivalent to RT or WT, that is read text or write text. Though the T is not mentioned, it is taken to be the default mode of operation. So now we will see an example of using binary files. You have the stdio.h, which is a very important header file, because the file is defined only in this header file. You have the conio.h main function. You are having the file pointer fp, which is a file pointer to open or close the file. You are having an integer variable over here. Then again you are checking whether the file can be opened, that is you want to write something into the file and you are checking whether it can be opened for WB, that is for writing in the binary mode. So this WB will check whether this bin1.dat can be opened in the fopen mode using this fp pointer. You are checking whether it is equivalent to null value. So here again the null should be in the uppercase. If it is equivalent to null, there will be an error opening the file. Otherwise whatever you want to write, you are going to write here values from 101 to 1100. So that is done using this fwrite statement. So what is this fwrite statement? You have already seen. It is equivalent to that argument that we showed below, ampersand ptrd, where ptrd pointed to the block of data that is to be read. So here you are having this I, this is only to be written. There the first argument pointed to the data that is to be written. Here I is the data that is to be written, that is why you are giving ampersand I. Then size of int, this is the size of the data block. How many ever integer values are there, that multiplied by 2, that is a byte of storage. Then you are having 1, only one block of data is being transferred from 101 to 1100. And then you are having fp, this points to the stream pointer. This pointer is obtained from this statement, fp is equal to fopen. So using which pointer variable you are opening that file, that stream pointer should be the fourth argument. So as long as the file can be opened for writing, you are going to this else loop. Using the for loop you are going to write all the data into the file, and after you write it, you close that particular loop and you close the file pointer fp. So with this the program is complete. Next is, this is an example for counting the characters in a file. This again you have a main function, you are having the file pointer fp. Here you are having two variables, one is a character ch, the other one is integer count. So here you are going to count the number of characters in a file. Here an important point to be noted is, here you are going to open this file in the binary mode. So having the fp pointer, using the fopen function you are opening the file name ex.dat in the RB mode, which indicates the binary mode. So this binary mode points to this file pointer fp, checking whether it is equivalent to null. If it is equivalent to null, then you obviously have to print that you cannot open the file. If not, else, you in the else loop, provided the file is ready for reading in the binary mode, using getC of fp, you are reading the characters into ch. Then using the do loop, you are counting the number of characters. Now here if you see, from the file fp, you are using getC and you are storing it in ch, and you are using count plus plus in a separate loop, that is the do loop. For each character that you are reading, for each getC of fp that you are storing it in ch, you are incrementing the count by 1. While not equivalent to file end of file fp, you are doing this particular work. So, this is a do while loop. While the file does not reach its end, as long as there is data in the file, you are incrementing the value of count and you are getting the character from fp, storing it in ch. So, for the number of characters, you will have the count incremented. Now, why is the count coming here in the previous line? Normally what will we do? We will have the count behind the getC function. Here you have already introduced a getC function before the do while loop. That is why the count plus plus is coming before the getC in the do while loop. Here already one character is obtained. So, for that the count has to be incremented, and again you are getting the characters, and for that you are going to keep incrementing the count as long as the file end of file is reached. So, finally you use fclose of fp and you printf the count value. So, here there will be a confusion as to you have had a text file, but you are opening it in the binary mode, and we all know that when we are reading binary files, we cannot use the getC and putC functions, as well as there is no file end of file character. So, how does this file end of file character come over here? The point to be noted here is we are using only text files, that is why we have a character. The text file is being opened in the binary mode and we are reading the characters from it. So, this file end of file character will obviously be present in the text file, provided there is no data with an ASCII code 26 prior to it. Because it is a text file, we will not be having 26 data ASCII code elsewhere. Only the mode is binary. The reading of data, the printing of data, so on can be done using the getC and the FEO functions. So, finally you close the FP file. So, here you are having only one file, you are just reading it and you are counting the characters and you are displaying it on the output screen using the simple printf statement. So, this is how characters can be read or written. Characters can be copied from text files in binary mode. So, the summary of today's session, we have the data files that we have seen, the unformatted data files, binary files, processing. In data files we have seen how to process the data and how to copy the files from one file to another. In unformatted data files we have seen that functions that are used, fread and fwrite, we have seen one example program with that. In binary files we saw how to open text files in the binary mode and how to read and to write data. So, the possible questions that could come in the session are the functions. What are the functions used to copy data files? So, the functions that we use to copy data files is, first you have to read from one file and you have to write into another file. You can use the fscanf and the fprint statement. In the case of text you can use getC and putC. What are the possible operations on data files? You can have reading, writing, copying and updation or appending. What are the significance of binary files? In binary files we normally use them to store machine language files as well as files which contain digits. What are unformatted data files? Unformatted data files are those which contain complex data structures like arrays and structures, and where you can read information only in the form of continuous blocks of data. What is the difference between binary and data files? Obviously, in the new line character, binary files to have only 1 byte of storage, whereas text files you have 2 bytes of storage. EOF character is not present in binary files, it is present in data files. So, these are the complete details of how the operations are done on data files, their basic concept, in what header files they are stored and how are the operations being done, what are the library functions used in them. So, with this the file system of C programming is complete. Thank you.